Hi everyone, in this video we are going to see how to find the equation of a circle that has an x-intercept of 2l and a y-intercept of 2m unit. Let's suppose we have a circle like this having the center at point C, coordinates h, k, and let's suppose it cuts the x-axis at points A and B and it cuts the y-axis at points D and E. In a problem, if we are given the coordinates of the center, then please understand that we are talking about a single circle, just one specific circle whose center is located at the point whose coordinates have been provided. Right? Now, if we are not provided with the coordinates of the center, however, we are provided with the radius and a few other information, then you know the circle can be in any of the quadrants. It can be in the first quadrant, it can be in the second quadrant, in the third quadrant, as well as in the fourth quadrant. So how would the circle look like if there is a possibility of a similar circle being present in the second quadrant? Well, it could look something like this. It can also have the same radius and at the same time it can have the same y-intercept and x-intercept. And similarly, we can have a circle like this whose center is in the third quadrant, and there also the circle can have the same radius and same x-intercept and same y-intercept. And also we can have a circle like this in the fourth quadrant having the same radius, similar x-intercept and similar y-intercept. So those are the four possibilities when we are not provided with the coordinates of the center. We are provided only with the radius, and from there we have to find out the four equations of the four possible circles. Next, I am going to drop a perpendicular from the point C onto the x-axis. Let's suppose the perpendicular landed at point P on the x-axis. So P will divide the chord AB into two equal parts. We have seen that in a previous theorem of circle that a perpendicular drawn from the center onto a chord would bisect the chord. So in this case, AB will be divided into two equal parts, AP and PB. AB is given as 2L unit. So AP will be equal to L unit and PB will be equal to L unit. And also CP will be the y coordinate of the center. Next, I am going to join the point C with B. So CB will be the radius. And then I am going to drop another perpendicular onto the y-axis from C. Let's suppose the perpendicular landed at point Q on the y-axis. So CQ will be the x coordinate of the center, and also Q will bisect the chord DE. So DQ will be equal to QE. Now DE has been provided as 2m unit. So DQ will be equal to m unit and QE will be equal to m unit. And here again I have connected the point C with the point E. So CE will be the radius of the circle again. And here I have made a few notes here. CP is perpendicular to AB and AP will be equal to PB will be equal to L unit. And similarly CQ is perpendicular to DE. DQ will be equal to QE, which will be equal to m unit. Next, we are going to take the first case where the radius has been given, the coordinates of the center are unknown. So in order to find the equation of a circle, we need three pieces of information, right? We need the coordinates of the center and we need the radius. Now here we have been provided with the radius, we have been provided with the x-intercept and the y-intercept, but we have not been provided with the coordinates of the center. That means there are four possibilities, right? So let's try to see how we can figure out the possible values of h and k. First, if we look at the triangle CPB, it will be a right triangle because CP is perpendicular to PB. So if we use the Pythagoras theorem on this right triangle, we can say that CP squared plus PB squared will be equal to CB squared, and that turns out to be k squared plus L squared is equal to R squared. And from here, k squared can be written as R squared minus L squared. And then from here we can say k could be equal to plus or minus square root of R squared minus L squared. Similarly, let's take a look at the triangle CQE. That is also another right triangle because CQ is perpendicular to QE. In that right triangle again, if we use the Pythagoras theorem, we can say that CQ squared plus QE squared will be equal to CE squared. And from here we can say that h squared plus m squared will be equal to r squared. And from here we can say h squared will be equal to r squared minus m squared. And then finally h will be equal to plus or minus square root of r squared minus m squared. Next, we are going to try and figure out the equations of the circles. So let's begin with the fundamental equation of circle. X minus h whole squared plus y minus k whole squared is equal to r squared. and if we plug in the value of h and k, then our equation going to look like this: x plus or minus square root of r squared minus m squared whole squared plus y plus or minus square root of r squared minus l squared whole squared is equal to r squared. And this represents a set of 4 possible equations, because we can create 4 possible equations from here using the plus or minus sign in the first parenthesis and the second parenthesis. There could be 4 combinations of that. Now let's take a look at the second case. In the second case, let's suppose we have been given with the value of h, I mean the x coordinate of the center. However, the y coordinate of the center and the radius of the circle are unknown. So let's see how we can figure it out. From the CQE triangle, again we can say CQ squared plus QE squared is equal to CE squared. And from here h squared plus m squared is equal to r squared. And from here we can say then r will be equal to square root of h squared plus m squared. Here I took the positive value because r is the radius of the circle. Radius can never be negative. Next, let's try to figure out the value of k. From the CPB triangle, we can say CP squared plus PB squared equals CB squared. And from there we can say k squared plus l squared would be equal to r squared. And from here we can say k squared will be equal to r squared minus l squared, and in place of r squared I have written h squared plus m squared. So finally looks like k squared is equal to h squared plus m squared minus l squared. And finally the value of k can be written as plus or minus square root of h squared plus m squared minus l squared. And in this case, since h has been provided, the circle can be either in the first quadrant or the fourth quadrant if h is positive. And if h is negative, then the circle can either be in the second quadrant or the third quadrant. So depending on the value of h, there are 2 possibilities. So in this case, we are going to come up with 2 equations of the 2 possible circles. So let's begin with the fundamental equation: x minus h whole squared plus y minus k whole squared is equal to r squared. And let's plug in the value of k and r. So from here our equation will look like x minus h whole squared plus y plus or minus square root of h squared plus m squared minus l squared whole squared is equal to h squared plus m squared. And that is the set of the 2 equations of the 2 possible circles when h has been provided but k and the radius are unknown. Next, we are going to look at the third case where k is given but h and radius are unknown. Here again, from the CPB triangle, we can say CP squared plus PB squared equals CB squared. And from there we can say k squared plus l squared is equal to r squared. And from here we can say r is equal to square root of k squared plus l squared. Here again I am taking the positive value of the square root because r is the radius. Radius can never be negative. And in this case, since k has been provided, which is the y coordinate of the center of the circle, if k is positive, then the circle can be either in the first quadrant or the second quadrant. If k is negative, then the circle can be in the fourth quadrant or the third quadrant. So depending on the value of k, there are only 2 possibilities, right? So in this case, we are going to derive only 2 equations like the previous case, like case number 2. Here also in case number 3, we are going to have 2 equations. Let's also find out the value of h. So from the CQE triangle, we can say CQ squared plus QE squared is equal to CE squared. And from there we can say h squared plus m squared is equal to r squared. And from here we can say h squared is equal to r squared minus m squared. That can be written as k squared plus l squared minus m squared. In place of r squared, I have written k squared plus l squared. And from here we get the value of h, which can be written as plus or minus square root of k squared plus l squared minus m squared. Now that we have been able to find out the value of r and h, let's now create the equations. We begin with the fundamental equation of circle, and then we are going to plug in the value of h and r. So then our equation going to look like this: x plus or minus square root of k squared plus l squared minus m squared whole squared plus y minus k whole squared is equal to k squared plus l squared. And that is the set of the 2 equations of the 2 possible circles when k has been provided but h and the radius are unknown. So essentially you have to remember one thing, that when the center is provided, meaning the coordinates of the center are provided, then we are talking about one specific circle. When nothing about the center has been provided, however the radius has been provided, then there are 4 possibilities. When one of the coordinates of the center is provided, then there are actually 2 possibilities. Case number 2 and case number 3, we have seen in each of those cases there are actually 2 possibilities because we have been provided with just one coordinate of the center. I hope things are clear up to this point. Next, I'm going to show you 3 examples. I'm not going to solve them here. I'm going to leave that for you to try. Let me know if I need to create a separate video to solve those examples. Please feel free to put a comment under this video, and if necessary, I'll create another video to solve those 3 examples. Now, here is the first example. The example says find the equations of the circles that have x-intercept equals 12 unit, y-intercept equals 16 unit, and radius equals 10 unit. And in this case, since only the radius has been provided, obviously there will be 4 possibilities, right? So the answer should include 4 possible equations. And here is the second example that says find the equations of the circles that have x-intercept equals 12 unit, y-intercept equals 16 unit, and center 6 unit away from y-axis. And if you look at the third example, there it says find the equations of the circles that have x-intercept equals 12 unit, y-intercept equals 16 unit, and center 8 unit away from x-axis. I hope everything made sense in this video. Thank you for watching. See you in the next video.